Welcome back, everyone. We're going to continue on this tutorial, and I think Ali is going to tell us about the societal aspect of data.
Thanks a lot, Biden. Thanks a lot, everyone, for joining us. So I will be talking about the societal aspects of data, in this second part of the tutorial. And I'm going to take a sort of a more, descriptive approach to data and data markets and privacy, and tell you about some of the societal concerns around, data markets. And this will be mostly based on joint works with Daron Acemoglu, Ali Reza Falla, Michael Jordan, Azar Ashmalikian, and Asuman and Ozak. There's the parts that are based on my papers are with these co-authors, and I'm going to talk about some of the other papers as well. So more specifically, so I'm going to have two parts. So in the first part, I'm going to talk about user and societal welfare in data markets. And there I'm going to talk about one paper in more detail. So this is a paper by Daron Acemoglu, myself, Azar Ashmalikian, and Asuman Ozdaglar on the sort of the policies around data markets. And hopefully I can convince you that they're interesting questions there to study. And those policy questions have been gaining a lot of attention. For instance, this work was cited in the 2023 economic report of the president. So there is a sort of active policy debate around data markets privacy, and there's a lot to be done in that area. And I will be talking about some of the other papers, and in particular, I will highlight the work by Dirk Bergeman, Alessandro Bonatti, and Tan Gan, which also talks about user and societal issues of data markets. And toward the end, I will be talking about some emerging topics and future directions. I really gave a sort of a motivation and introduction, but let me have like a few slides to sort of tell you about sort of the societal aspects of data markets, and what do I mean by that. So I guess there's no doubt that our lives have been improved by technology advancements, and we use many applications sort of for free. But one thing is, or one catch is, most of these applications and products are founded and funded by data. They're being improved by user data, personal data of users, and with some of their applications, they generate revenue from advertisers, or perhaps by explicitly selling data. And so what is the concern with these applications, these data-enabled applications? So one concern is privacy concern, and this has been highlighted by recent scandals such as Cambridge Analytica, where they collected data of just like 50,000 or 70,000 people, and from there inferred information about or got access to information about millions and millions of people. And what is highlighted in that example is this social aspects of data, that the data of one individual can tell you something about others, and that will be the main focus on of at least the first part of this talk. And the main question we're going to sort of study is, given that social aspect, given that data externalities, what are the appropriate business models for data market? For instance, is it enough to just give people control over their data? So is that going to resolve the concerns around privacy, or we need something more? That's going to be the discussion I'm going to have at least in the first part of the talk. And so I guess when it comes to data markets and privacy, the main features that we should have in mind, and Ali Reza talked about some of those as well, is there's no unified definition for privacy. People consider different definitions, and for different applications, one should use different notions. So the other, feature is people are not clearly aware of how their data will be used. And one thing I'm going to sort of highlight the most is this third bullet, the correlation among individuals' data or individuals' personal data. And by that I mean, if I share data, I will be sharing about my friends and my colleagues. If I share my data, I will be sharing something about Ali Reza, for instance. That's going to have consequences, and we're going to see what would be the consequences of those sort of data externalities. And in particular, we're going to see how does these correlations affect the equilibrium prices for personal data. Can we have equilibria that sort of benefit both the users and the platforms? And what are the implications in terms of the welfare of the individuals and also the welfare of the society? And what can we do to improve the welfare? So what sort of policies and regulations can help us to improve the societal welfare? So more specifically, in the first part of the talk, I'm going to develop a model in which data sharing by one user reveals something about others. So there will be this data externalities. I'm going to establish the basic properties of information measure. I'm going to define it. I should recall what that is already defined, and tell you about the properties that will be essential for our characterization of the equilibria. I'm going to talk about the efficiencies of these sort of markets, talk about generalizations, and toward the end talk about some of the implications of data markets, and what can be done to improve the outcome of data markets in terms of the societal welfare. So that's that. So let me tell you a little bit about the literature, and then I'm gonna talk about the model and the results that I want to share with you. So we're going to relate to sort of two streams of literature. So one is on sort of privacy concerns. This dates back to the works of Justices Warren and Brandis. Many law scholars have worked in this domain. Many economists have worked in this domain. Many computer scientists. And here I have only a few papers listed here. We also relate to the information markets. Data and information markets, so they're closely related. But most closely related are the papers that study data externalities. And I want to highlight two papers in this domain and tell you how they relate to what I'm going to tell you today. So in particular, I want to highlight this work by Bergman, Bonatti, and Gann. So what they consider is we have users, and we have an intermediary who collects user data and is going to sell that data to some platforms or firms who are going to use that data to price discriminate. So in what they consider, there is really like three sides. There is this. It's a two-sided market. So there is this intermediary in between. It collects data from users and then it sells it off to firms. And what they consider as privacy concern is the firms can use information about customers, about consumers, for price discrimination. So basically, privacy loss in their model will be the loss of user utility because of price discrimination. So that's that. And what they show is data externality is going to reduce the intermediary's cost for collecting data, and this will hurt users. So in what I will tell you, the same mechanics apply. So basically, the main reason for this loss of user welfare is very similar to what I'm going to tell you about in our paper. So we're not going to consider an intermediary. So we're going to consider platform directly collects data from users, and we're going to sort of in an abstract way define privacy concern. Whenever my information is leaked, I will have some loss in my utility, but one can, in principle, use price discrimination again. And that's that. So the other paper I want to highlight is this paper by Ichihashi, Dynamic Privacy Choices. And again, the same mechanics as what I'm going to talk about today exists in that paper as well. So he considers a dynamic privacy choice. I'm going to over time decide how I want to interact with the platform. How much information I want to share with the platform. And the data externality in this paper is sort of between my data today and my data tomorrow. So if I share more data today, then that reveals something about my data tomorrow. And the results in that paper are pretty much because of this data externality. Again, the same mechanics that I will be talking about today, exist in that paper as well. All right, so let me tell you about the model, and then I'm going to tell you about the data externalities and so on. So how do we define the information? So we have end users. Think about them as data holders on a platform. Each user has a personal type, say xi, and let's assume for now this is normal. It means 0 and some variance sigma I squared. Is that going to be important? Well, not really. So hopefully I can convince you that, so I'm going to develop the model with Gaussian signals, but hopefully I can convince you that, most of the results that I will be presenting, they sort of extend to settings beyond this, normal signals and the specific information measure that I will be talking about. So for now, again, let's say we're going with normal signals, but I will tell you how one can extend this. So that's that. And the user types are correlated, and this correlation is captured by this matrix sigma. So, I guess unlike what I was talking about, the data are not IID. My data can tell something about Ali Reza's data. So there is this correlation here in this model. And the platform wants to learn, these types, these personal types, x1 to xn. How does the platform do that? So the platform is going to offer different prices in exchange for personal data. So let's say the platform is going to offer price pi in exchange for personal data of user I, and that personal data we assume is going to be xi, the type of user I, plus some noise zi. So that's that. So with this in mind, so how can we think about privacy loss or leaked information? So once the platform offers these prices, a set of users are going to decide to share. So let's have a notation for that. So I'm going to say AI is the action of user I. It's 0 or 1. So it's 1 if user I shares her information, shares her personal data. So this vector A is going to be the vector of user decisions. So that's that. And given that, the information available to the platform, so I'm going to denote that by S sub A. So that's simply the signal of the users who have shared. So that's that. So it's the SI for the AIs that are 1. Now with that, again, this is sort of to remind you what I has already talked about. The leaked information or revealed information of user I is going to be the reduction in the mean square error of the best estimator of user I type. So again, it's this expression here. Why is that? So if the platform doesn't have any information about user I, then the mean square error of the best estimator is going to be sigma I squared, the variance. And if the platform has some information, then the platform can do better, can go with the best estimator. And the difference between these two, that's going to be the revealed information or leaked information about user I. And again, this is sort of repetition of what Alireza was telling you, but I think it's very important for our discussion. So let me highlight it again. So there are two properties of this notion of information leakage that we'll be using a lot in our analysis. So one is submodularity. So basically what that says is as more users share their data, the marginal increase of this information leakage is going to decrease. The marginal increase basically is, the difference between the leakage when I share and, when I don't share. So that's going to decrease as more users are sharing data. So that's that. So this will be satisfied for this particular, measure of leaked information. And the second one is monotonicity. That simply says, more people are sharing, my information will be leaked more. So this leaked information is monotone in the set of users who are monetarily increasing in the set of users who share their data. So these two properties are very important. So pretty much
So
anything I'm going to
Alireza,
tell.
sorry, Ali, sorry. Can I ask you a clarifying question? These two are strict or weak? So is it like weekly increasing and
Very good. Yeah, it is
or
weekly increasing. That's right.
it's
That's right.
weekly?
So
Okay.
as long, yes. So you can imagine if, my data is uncorrelated with someone,
Yes,
then
exactly.
their
Very
sharing is not going. Yes, weekly increasing.
perfect.
Correct. Correct. That's right.
Thank
That's right. Very good point. Very good point. So this will be, I mean, these two properties are pretty much all we need in the analysis. So all the inefficiencies are going to go through as long as we have these two properties. So for instance, I guess in the paper, we come up with some other examples. So for instance, one can think about some information theoretic measures of information. And as long as you have these two properties, everything I'm going to tell you is still going to hold. So that's why I wanted to highlight, these two properties. That's that. And they in particular hold for this definition of leaked information. All right, so that's that. So now one more definition. So what are the payoffs in this setting? So if I look at the platform, so the utility of the platform, the payoff of the platform is simply going to be the sum of the information leakages minus the sum of the payments that the platform needs to pay to the users who share the data. So that's it. So sum of the leaked informations minus some of the PIs for those AIs who are sharing the data. And think about this payment. I guess I'm not explicitly defining, what this payment looks like, but you can think about this as, either direct payments. Alireza had, some examples of that, or, this could be some free services that you get in exchange for sharing your data. So that's it. So how about the payoff of user? So if I look at user I, the user I has, like a binary action. So either she's going to share or not. So if she shares her data, AI is 1, then her utility is going to be the payment she receives minus some privacy loss. So how do we model this privacy loss? So it's going to be some parameter VI. So that's going to be the value of the privacy times the leaked information of user I. So how should we think about this user I's value of privacy? So we wanted to give users heterogeneity in terms of how much they care about privacy. So if I care a lot about my privacy, then my value that's going to be very large. If someone else doesn't care about their privacy, then their VI is going to be tiny. So people are going to be heterogeneous in terms of how much they value privacy. And if user I does not share, if AI is 0, then there is no payment, and there is only minus VI times the leaked information. And one thing to highlight, the difference between the leaked information in the top line versus this one at the bottom is, so here AI is 1, I have shared, and naturally this leaked information is going to be higher than this one at the bottom. So here AI is 1, and here at the bottom AI is 0. So that's it. So how about utilitarian welfare or social surplus? That's simply going to be the sum of all payoffs of the platform and the users. That simply is going to be 1 minus VI times the leaked informations, because the payments, they're going to cancel out. So that's that. Any question about the model? Very good. All right. So I'm going to have one slide on the equilibrium. I guess the takeaway here is equilibrium exists, so we can talk about its properties, but let me formally define that. So for any price vector P, the price that we offer to each one of these users, we say an action profile is user equilibrium if each user is playing best response given the action of others. And this may not be unique. So we let cal A of P be the set of all user equilibria. But of course, we need to show this set is well behaved, it exists, it's not empty, and so on. That is true. So here's a sort of a simple proposition. So for any vector P, this set is a complete lattice, and therefore it's non-empty. It has a largest and a least element. And the proof is a simple application of Tarski's fixed point theorem. So that's that. So we can talk about user equilibrium. But how about the equilibrium for both the platform and the user? And that can be defined as the Sackler-Berg equilibrium. And basically what that means is an action profile and a price vector where the platform doesn't have any profitable deviation and the users, they're playing best response as well. And formally, and this is going to be the definition of Sackler-Berg equilibrium in our setting. And we show this exists. Again, not going to go over the detail of the proof. So the bottom line here is, we can talk about the properties of the equilibrium. The equilibrium exists, so we can talk about its properties. So instead of talk about the proof of this, I'm going to go over one example to sort of tell you how the equilibrium looks like. And I guess at the risk of sort of trivializing, what's going to come next. So I'm going to tell you all the insights, in one example, and then I will tell you, that they hold, more generally. So I'm going to consider like an example with like two users, where the values are the same, v1, v2, they're both equal to 1, and the cross correlation is rho, some parameter rho. And the question I'm going to ask is, is the total payment monotone in the set of users who share information? So I, as a platform, if I want to collect the data of more people, do I need to pay more or not? So let's see, what is the answer to that question. So here is the user equilibria as a function of the price vector. So here on the x-axis, I have the price offered to user 1, and the y-axis price offered to user 2, and each one of these regions is a region where we can have an equilibrium. If I look at this blue one, for instance, so here the equilibrium is both of them are going to share. This red one, the prices are small, so we're not providing enough incentives, and none of them is sharing. If I look at this green one here, P1 is small, so A1 is going to be 0, P2 is large, A2 is going to be 1. So only user 2 is going to share here, and only user 1 is going to share in this other green region. So that's that. And if I play with this rho, with this correlation coefficient, so I can get to a picture like the one we're seeing now. So what happens here is, if I look at this, black line here, so the sum of the payments here is constant, right? And I have some equilibrium in which I'm getting the data of one of the users, and some equilibrium in which I'm getting the data of none of the users. And as I increase this correlation coefficient, as I increase this rho, there will be a threshold. And here in this particular example, that threshold is 0.71. It's not important what that number is. This exists. Where we get to this other picture. So what do we see here? So again, on this black line, the sum of the payments is constant. But what we see here is, if I look at this one here, for instance, this equilibrium. So with the same total payment, so here both users are sharing. So again, so here, oops. So here, none of them is sharing. So here, one of them is sharing. But with the same payment, I can have both of them sharing. And this already answers, the question I was asking, right? So the total payment is not necessarily monotone in the set of users who share information. So again, what that says is I can, in principle, get more data with lower overall payment. And that's one of the sources of inefficiencies in this market. And that is enabled because of this data externality. And in particular, you see that if the data externality is strong enough, then this will be possible. So that's that. And hopefully I can convince you this holds more generally, and I'm going to show you, the formal result. What else? So again, playing with the same example, I'm going to ask this other question. So is surplus monotone in valuation? So let's look at the surplus of the equilibrium and see how that behaves as a function of the valuations. So again, the same example. And here in this plot, on the x-axis, I have the values, V1 and V2, they're equal. And on the y-axis, I have the surplus in equilibrium. So what we see here is, if the values are small, so let's say, less than 1, the surplus is positive. So after a certain, threshold here is 1, up to, this other threshold, the surplus is going to be negative. So both of them are going to share, and the surplus is going to be negative. And if the values are large enough, then none of them is sharing, and the surplus of the equilibrium, that becomes 0. So what I want to highlight in this picture is, there is this intermediate regime for the values where the total surplus is negative. So the societal welfare, I guess, in this example, so that's going to be negative, and we'll see, it's not limited to this particular example. So that's something that holds, more broadly. All right, so that's that. So I guess in the rest of this first part of the talk, I'm going to formalize, these observations more broadly. But before that, so I want to tell you about price characterization as well. So this will not be important for, the inefficiencies that I will be, talking about, but I think it sort of highlights what I mean by data externality. So it sort of clearly captures the network externality and, these data externalities. So what do I have here? So I want to characterize what would be the sort of the optimal price that the platform needs to offer for sustaining any action profile. So let's say we want to have user I sharing, and the other users will take some action. So the optimal price is the one that makes the user indifferent. So meaning, the utility of user I when she shares is going to be the same when she doesn't. So if you work this out, the optimal price then is going to be this expression. And here we have the difference between the information leakage when user I shares and when she doesn't share. And this has a sort of a nice characterization. So let's look at this. So the leaked information when user I shares, we can decompose it into sort of two components. So the first one is a network effect. So the leaked information when user I is not sharing. So that has nothing to do with the data of user I, with the sigma I, for instance, the correlation, the variance of the data of user I, and a second term that is going to be the user I's effect, and this now will depend on sigma I square. So that's the variance, basically the intrinsic uncertainty about the data of user I, and also the network effect. So here we can clearly see this data externality. It has two parts. So one is the network effect, and the other one is what we get in addition when user I also shares. And using this, one can come up with the sort of explicit characterization of the prices. So I'm not going to talk about this in detail, but just tell you that there is a way to explicitly characterize the equilibrium prices as a function of the underlying correlation structure, as a function of this sigma, the correlation matrix. So that's that. Now let's talk about the inefficiencies. I'm going to have one more definition, and then I can tell you the main results of this paper. So here I'm defining low value users and high value users. So low value users are the ones whose value is less than 1, and high value users are the ones whose value is larger than 1. So what is specific about this number, this 1? So if you recall, in the payoff of the platform, the coefficient of the leaked information was 1. So here, basically, low value user means the users who care about privacy less than the platform, and high value users are the ones who care about the leaked information more than the platform. So if those coefficients are different or if they're heterogeneous, then one can modify these definitions nothing, very specific about that. And one simple lemma that we can show is in any equilibrium, all low-value users are going to share their data. They simply don't care about their privacy, so they're going to share their data. Now with that in mind, I can tell you, the kind of inefficiencies we get in general. So the first part of this theorem says, suppose high-value users are uncorrelated with others, then the equilibrium is going to be efficient. So the equilibrium is going to coincide with the first phase. So what this says is, if you have people who care about privacy in one island and people who don't care about privacy in another island, then data market is going to be efficient. So there is no cross correlation, and creating this market for personal data is going to be efficient. I guess that almost never happens. So now let's consider some cross correlations. So the second part says, suppose at least one high-value user is correlated with a low-value user. Then if this high-value user's value is large enough, then the equilibrium is going to be inefficient, meaning the surplus in the equilibrium is going to be negative. So this, in the second part, what it captures is the inefficiencies we get from externality. So what do I mean? What do I mean by that? So here, I care a lot about my privacy. Say, Alirez, because I'm using Alirez. Say Vahida doesn't care about her privacy. So now, if Vahida shares her data, then that will reveal something about my data. And if my value for privacy is large enough, then this will make the welfare negative, makes the social surplus negative. So that's what this thing is saying. My data will be revealed. I care a lot about privacy. My data will be revealed if someone who doesn't care about privacy shares her data. So that's what this second part is telling us. So now there is another, sort of perhaps more interesting inefficiency that exists in this market. So now forget about, the correlation between high and low values. So let's focus on high value users. And let's say there is no cross correlation to low value users. So if I have, correlation between high value users and their values are not too large, are sort of intermediate. So this is very similar to the example I was showing you before. So if the values are high but intermediately high, then again the equilibrium is going to be inefficient. And the reason here is not because of the correlation anymore, is because of the depressed prices. So basically, you and I, we both care about privacy. So let's say, okay, Alireza and I, we both care about our privacy a lot. But because there is this correlation between our data, the moment you create a market for data, we end up competing with each other. And we're going to get very marginalized prices, and the equilibrium is going to be inefficient. So that's that. But then you may say, well, inefficiency is not perhaps is not the best way to sort of say there are issues with data markets. So can we quantify the extent of the inefficiency? So I guess here by inefficient, I mean the surplus in equilibrium is negative, but can we quantify that? So can we say what are the surplus that we get in equilibrium? So let me tell you about that as well. So I want to bound the social surplus that we get in equilibrium. So we have two set of users, low value users and high value users. So I'm going to look at the low value users and say, they're going to contribute 1 minus VI times the leaked information in equilibrium to the social surplus. And I'm going to bound this by 1 minus VI times the leaked information if everyone is sharing. So here 1 minus VI is positive, so I can do that. But if I look at high value users, 1 minus VI there is negative. So I need to lower bound the leaked information. How do we do that? So I say, in equilibrium, I know the low value users are sharing. So 1 minus VI here is larger than 1 minus VI, the leaked information, if only low value users share. And we get this kind of bound in the social surplus in equilibrium. And if you work this out. So this gives you a condition under which shutting down the market is going to be is going to improve the societal welfare. So of course, this is a sort of a draconian, I guess, regulation or policy, simply shut down the market. But at least, what this result shows is, it is possible, if you have, I guess, in terms of the primitives, what this says is, if you have sufficiently many high value users who have, sufficiently high correlation with the low value users, then, shutting down the market is going to improve the social welfare. Again, this is a draconian regulation or policy, and we're going to talk about some of some other regulations and ideas that can potentially improve the social surplus. All right, so I told you about the results hold more generally. So let me mention it here again. So if we relax the functional form and simply assume that the sort of the information leakage, whatever you want to define it, it has these two properties, monotonicity and self-modularity, then everything I talked about continue to hold. We still have inefficiencies in data market simply because of data externality. So some other generalization that I'm not going to go over them in detail, but so here we assume that we do know the VIs of users, the value of privacy for each user. But I guess more generally, we may not know that, and we extend our results to that. I guess in that setting, we use some tools from mechanism design, and pretty much all you need to do is to replace the values by virtual values, and similar results are going to hold in that setting as well. Again, one assumption was the correlation structure is known. What if it's not known? Again, the same results are going to hold as long as we have some belief over that. Some common belief over that, the same results are going to hold. And the other thing that I'm going to come back to this toward the end of the talk is what if we have competition among platforms? So can that help perhaps to improve the social welfare? And the short answer is competition does not necessarily help, and it may as well worsen things. And the main reason is, once you have, say, two platforms, the users are going to join one of them. And once you have users locked in on one of the platforms, then the same forces exist. Once you have users on one of them, then again, the data externalities are going to make things inefficient. Again, I'm going to come back to this competition idea toward the end. So I want to sort of tell you about another regulation that we propose. We're not claiming that this is something that one can implement, but I think it's sort of interesting to go over this as one sort of idea that can potentially be used. So we call this decorrelation or mediated data sharing. So how does it work? So we're going to have a sort of a trusted mediator who is going to collect the data of users. And it's going to decorrelate them. Decorrelation is simply this linear transformation, and the property of this linear transformation is the following. So it's going to make the data of user I with the data of the rest of the users uncorrelated, and it's going to have the data of user I with the S hat of I with the corresponding transformed data of user I's to be correlated. And the property that this will imply is, if I look at the leaked information now with the correlation, the leaked information, if I share, is going to be the same as what it was before. And if I don't share, then it's going to be zero. And then that's a good property, right? So basically, this is going to remove the correlation between any user who doesn't wish to share and all other users. So if I don't want to, if I'm very concerned about my privacy, I don't want to share, then nothing about me will be revealed. So that's basically what this says, and this is going to help to some extent. So what we show is the social surplus with the correlation is going to be non-negative always, and it's going to improve upon the social surplus without the correlation. So again, I'm saying this is not implementable because to implement this, you need a trusted third party, which I guess we don't have. But if we can come up with some ideas on how to implement this, that can potentially help. And the core idea is quite simple. So the main issue was correlation. And what this decorrelation does is, make sure that, my data is sort of decomposed into two parts. So one that is orthogonal to, everyone's data, and one that is related to other people's data. And if I decide to share, I'm only sharing the part about myself and nothing about others. So that's basically what this decorrelation means. All right, so let me wrap up the second part. I don't have that much time, but I want to tell you about some of the future directions as well. So far, I argued that data externalities can, result in depressed prices and, inefficiencies in data market. But what about, some of the other issues in data markets? So let's talk about those. So one solution is, you may say, well, let's just give people, ownership over the data. So that should help. So there are some issues, with that. One is in particular, what does it mean to have, ownership over data? So how does the copyright work, especially with, AI models, with AI generated content? How does the, copyright works? There are very interesting, discussions around that, and some of those are still unclear. But besides that, even if it's clear, what does it mean to own like some data set? Even with that, I guess what we argued is, this data externality still, leads to some inefficiencies in data markets. And the main reason, again, just to repeat, is the societal aspect or the social aspect or data externality creates a race to the bottom in prices and makes the market inefficient. So that's the bottom line of what I've told you so far. But how about some of the other issues? So far, I was telling you, well, I have my data and I decide whether I want to share it or not. But if you think about it, in many sort of applications, it's not like, I have my data somewhere and I decide whether I want to share it or not. I have to, go ahead and produce my data. So if you think about it, AI models, depend on high quality data, most of which, need to be produced. I mean, for instance, GPT-3, 4, they were trained on, existing data often produced, for instance, books, Wikipedia, or, Stack Overflow, information, for instance. And, this kind of data, I mean, for instance, books, people have to, produce books or write books. So there's this very interesting paper that basically documents as soon as, ChatGPT was released, the amount of traffic and the production of data on, Stack Overflow collapsed. So, and you do see the picture here. And I think, there's a very interesting, question and observation here to be studied. And no similar collapse was observed in the Math Overflow or in the Russian or the Chinese versions of the Stack Overflow, because ChatGPT was blocked in these languages at the time. So what does this suggest? What's the problem here that I think is quite interesting? So this says data markets may under provide incentives. So if data prices are zero, users are not getting paid for sharing data. Users will not invest in producing high quality data. And what this suggests is this demands some new design. So if everyone can use ChatGPT to produce books, then I guess no one is going to write books. So we need different design, or I guess in terms of the Stack Overflow is a better example, because people do make revenues from selling books. But the Stack like Overflow or Wikipedia. So if we can generate content with AI, then you're not going to spend time on that. So this requires some new design to provide the right incentives for people to produce high quality data. That's that. And some of the other ideas, I'm going to finish in like 3 minutes. So I'm going to go 2 minutes over time, if that would be fine, Mahida. Hopefully it's going to be fine.
Yeah,
So
that's okay.
perfect. So the other idea is, or the other solution is, what if we change the architecture of the data market? So let's say we allow data market, but with collective ownership. So far I told you that if each individual has control over their privacy, then there is issues. But if all of us collectively decide, then things are going to be fine. And for instance, there's this idea of data unions proposed by Jaron Lanier, Glenn Whale, Eric Posner, among many others. And what they sort of suggest is, what if we all pull our data together, and then if someone wants to use our data, they have to get, for instance, some subscription, or some other form of, they have to pay the union to get our data. And then this union has to pay the users back. And there are many interesting questions around how would you design the compensation there. So if you have a data union, you're using the collective data of users, but you have to pay them back. How do you do that? So there are some interesting questions around that as well. And there's a sort of a precedent for such arrangement. For instance, with Writers Guild of America. So basically, they protect all writers collectively, and that's the same idea with data unions. Again, going back to the competition idea, so I told you, competition is not going to work, and the main reason is because, so if you have multiple platforms that are offering the same privacy protections, then there is not much to compete over, right, for the platform. But what if you sort of have platforms with different architectures? So here are two ideas. So for instance, you may want to have data pods, for instance, as proposed by Tim Berners-Lee. So basically, whoever wants to get your data, they have to ask you, or in any way they want to use your data, they have to get permission from you. So that certainly can help. So the other idea that is out there is portability, and what that says is what if you sort of allow individuals to sort of carry their social network information when they change platform. So if you go from platform X to, well, there's a platform X. So if you go from platform A to B, then you can carry over your social network information. So that's that. So I'm going to end here with sort of another sort of challenge, which I think is interesting, and hopefully you'll find that interesting as well. And this is based on a sort of a recent paper we wrote together with Darun Asamoglu, Azarash Malakian, and Asuman Ozeglar. So far, I told you about privacy concerns. And if you look at the literature, the privacy concerns, they're sort of modeled or thought of as either intrinsic privacy, I care about privacy, and if that is lost, then I'm going to incur some cost. Or it's because of price discrimination, because you as the platform, or you as the firm, can use my information to hurt my payoff or my utility. So what we argue is there is sort of another reason that can potentially result in privacy concerns, or make users hesitant for sharing their data, and that's going to be behavioral manipulation. And what that means is the ability of data empowered platforms to manipulate users for gain. And there are like many examples of that in this book, The Age of Surveillance Capitalism by Shoshana Zuboff. And basically what we do in this paper is we develop a theoretical framework to show how platforms' recommendation system or algorithm, together with having more information about users than perhaps themselves, can lead to behavioral manipulation. So again, I'm not going to go over the detail of this. Happy to talk about this in the Q&A or offline. All right, so let me stop here and just say, hopefully we have convinced you that there are several exciting directions at the intersection of data, algorithm, incentive, and societal issues. And if you find any of these topics interesting, we're more than happy to talk about them further. Thank you.